Countries have to provide facilities for their nationals to do front-rank research within the resources that are available. It is equally necessary, having produced the men who can do research, to organize task-oriented projects for the nation's practical problems. Dr. Vikram A. Sarabhai founded the Physical Research Laboratory with this vision. The passion with which he uttered these words can still be felt in the reverberations of the campus. Physical Research Laboratory, or PRL, was founded in November 1947 with Professor K.R. Ramanathan as its first director. The research activities then were focused on atmospheric sciences and cosmic rays. In the beginning, the laboratory occupied a few rooms at the MG Science Institute. With the expanding activities of the laboratory, the need for its own campus was realized, and in 1952, Nobel laureate Sir C.V. Raman laid the foundation for a separate premises for the laboratory. After 2 years, the first building of the present campus was inaugurated by the late Prime Minister Jawaharlal Nehru. During the 60s, the use of rockets and satellites for studying the outer space and exploring the Earth gained considerable momentum. Dr. Sarabhai and his young band of scientists from PRL realized the potential of these studies and began detailed investigations of the upper atmosphere with specially designed scientific payloads flown in rockets and balloons. A new era of space science research thus began in India, and PRL rightly earned for itself the distinction of being the cradle of our country's space program. These studies led to new ideas and interests among scientists of the laboratory, which paved the way for the expansion of its scientific activities and campuses. Currently, PRL has 4 campuses located at Ahmedabad, Thaltej, Mount Abu and Udaipur.
In these 50 years, the laboratory's strength and its scientific activities have grown tremendously. The science at PRL has also grown significantly and currently covers a very wide range in various areas of astronomy, planetary and space sciences, earth sciences, theoretical physics, lasers and quantum physics. During the past 5 decades, we have made considerable achievements in the frontline areas, glimpses of which are being presented in this documentary.
From the dawn of civilization, men have questioned about the creation of the earth, sun, and the forces of nature. Even today, these questions continue to be topics of inquiry and debate among scientists and laymen alike. Clues to the origin of the solar system bodies, including the Earth, are found in meteorites, the space messengers which bombard the Earth once in a while. These extraterrestrial objects store these clues in the form of chemical and isotopic signatures. PRL scientists decipher these records to characterize the various processes that have occurred during the formation of the solar system and determine their time scales. These studies rely on the use of sophisticated instruments such as mass spectrometers and radiation detectors. Using similar experimental approaches, scientists from the Earth Sciences Group address issues on the evolution of the Indian lithosphere, especially its surface features. The group pioneered in providing a geochronological framework for the evolution of the intimidating landforms, the Himalaya and the Deccan Traps. The precise age determination of the Deccan Traps also set to rest the hypothesis that the Deccan volcanism is the cause of one of the most dramatic global extinction of life forms, including the dinosaurs. Geochemical studies of the layers of sediment deposited during this time from Anjar and Meghalaya by PRL scientists confirmed that this extinction resulted from the impact of large extraterrestrial objects on the Earth. India is an agricultural country and depends on the monsoon for its food production. Over the past few decades, there is a growing interest among scientists and policymakers to understand the monsoon variability and the impact of industrialization and agricultural practices on the climate. A major activity at PRL has been to retrieve records of paleo-monsoon of India and its adjacent regions. This is achieved through careful isotopic and chemical analysis in tree rings, corals, glaciers, sediments from lakes and the sea, peat bogs, and depositional history of sand in desert dunes. These measurements provide proxy climatic data, which serve as inputs to climate models. The radiocarbon lab of the group provides chronology for samples used in paleoclimate studies, in addition to serving as a national facility. Of more immediate concern is the propagation of monsoon within a season. The theoretical climatologists study these processes through atmospheric circulation models. Oceans are the heat engines of the climate system, and their circulation exerts significant control over Earth's climate. PRL scientists have been actively involved in the studies of surface and deep water circulation of the oceans and particle dynamics in them by using environmental radioactive isotopes. PRL's programs in hydrology have helped quantify groundwater recharge and movement in several areas of Gujarat. These studies have conceptualized Akshayadhara, an approach which relies on the renovation and reuse of waste and stormwater through soil aquifer treatment. Another component of the Earth system is the atmosphere, which protects all life forms. This thin, tenuous layer is being continuously bombarded by intense solar radiation from up above and influenced by both natural and man-made activities from down below. Studies in atmospheric sciences at PRL began with the measurements of the distribution of ozone in the early 50s using the Dobson spectrophotometer. This research continues to be one of the active programs of the group even today. In recent years, the ozone distribution is being modified by pollutants released into the atmosphere. These pollutants also influence atmospheric chemistry and climate. PRL has a major program to measure the distribution of these pollutant gases and evaluate their source and sinks in the atmosphere. Towards this, scientists collect air samples from various altitudes using cryogenic air samplers flown on board balloons. The collected air samples are analyzed in the laboratory using sophisticated instruments such as gas chromatographs and mass spectrometers. Apart from greenhouse gases, tiny dust particles in the atmosphere, known as aerosols, also affect the radiation balance, weather, and climate. An automatic sun-tracking multi-channel photometer is used for the measurement of aerosol number, density, and size distribution. Using LIDAR, light detection and ranging technique, PRL scientists probe the atmosphere with high-powered pulsed lasers up to 80 kilometers to obtain the distribution of aerosols with altitude. Unlike the lower atmosphere, the upper atmosphere is ionized due to the incoming solar ultraviolet radiation, X-rays, and cosmic rays. The low and equatorial regions display several unique geophysical processes. Rocket experiments are conducted from the magnetic equator to probe the ionosphere. Continuous monitoring of the ionosphere and its response to various energy inputs are made using ground-based ionospheric sounders. At different heights, continuous chemical reactions in the upper atmosphere give rise to faint emissions known as air glow. Ground-based photometers and imaging cameras have been employed to monitor these faint emission intensities from the sky to infer atmospheric and ionospheric properties. High-resolution spectrometers are employed at Mount Abu to monitor the air glow to derive neutral temperatures and winds. To measure the faint emissions in the daylit conditions, PRL scientists have developed a day-glow photometer. The study of ionospheric regions is associated with a theoretical understanding of plasma processes which go even beyond the boundaries of the ionosphere and magnetosphere. Theoretical plasma physics has in fact been one of the earliest interests of the laboratory, wherein studies were made of the phenomena of VLF emission and magnetic field reconnections at the magnetosphere. More recently, the theoretical studies in this field have been extended to understand dusty plasmas, both in space and astrophysical environments. To understand the complex atmospheric and ionospheric processes, which involve a variety of reactions between photons, electrons with atoms and molecules, an experimental facility has been set up to simulate some of the interactions and study in detail their consequences. Theoretical investigations of atomic collisions are being made, which are of interest in the context of both atmospheric and astrophysical processes. The facilities include a high-power excimer laser to determine the rates of various reactions, photoabsorption, and fluorescence cross-section in the extreme ultraviolet range. By virtue of its proven precision, laser has emerged as a frontline technology. The newly set up Laser Physics and Quantum Optics Group at PRL is carrying out research in the fundamentals of lasers, their applications, and on the quantum characteristics of optical systems. The group has found that the optical properties of materials can be manipulated by using appropriate electromagnetic fields. Other exotic yet commercially significant topics such as self-imaging waveguides, optical vortices, and pattern formation have also been studied theoretically.